Now welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a GCSE Maths revision of Algebra, looking at some exam questions taken from the foundation syllabus. Now as always, I'll include a copy of the questions that we go through in this video in the link in the description, which I strongly recommend you have a go at before watching through this video as we go through the answers. I'll also include a question breakdown so you can see which question refers to what topic or what area of Algebra, and I'll also include a link to the contents page of 162 Maths in case there are particular topics or areas that you're not familiar with. Basically those links will take you to lessons which go through it in more detail. Now before we get started working through some questions, a little quick disclaimer that not everything covered in Algebra is going to be tested on this audit. So although it covers majority of the topics, it doesn't go into detail about all the types of questions that could arise from each of the topics. They are just a collection of common questions. Now again, in terms of what's covered in this particular audit, you're looking at algebraic manipulation, so looking at expanding, factorising, collecting like terms and simplifying. You're looking at substitution, formulas, expressions, equations, identities, and knowing what they are as well as working with them. Inequalities, factorising and solving quadratics, rearranging the formula, function machines, writing formulas and equations, coordinates, plotting graphs, writing the equation of a straight line or y equals mx plus c, graph shapes, real life graphs, time distance graphs, solving equations, number lines, simultaneous equations, writing expressions and sequences. Now again, a little reminder that a copy of the questions that we're going to go through shortly is available for you to download and have an attempt at, which I strongly recommend that you do before watching through this video as we go through the answers. Now before we get started working through these questions, a little brief disclaimer, the fact that some of these questions may appear on both the calculator and the non-calculator paper. So just for revision purposes, we'll assume that all the questions are non-calculator unless it particularly becomes more difficult without using a calculator. But then if we do get these questions on a calculator paper, it will be a bonus. So looking at question 1, it says match each expression on the left to one on the right. The first one has been done for you. So all we need to do is just remember our rules of algebraic manipulation of collecting like terms, simplifying expressions to try and find what the answer is going to be. So as the first one's done for us, the second one is a plus a plus a. So when we're adding, we're just adding the quantities together. So what I can see there is 4a. So the correct answer is going to be going to the fourth box. The next one is 4 times a times b. Now when you're multiplying, you just merge the things together. So what we're looking for here is 4ab, which is our very first option. And again, it doesn't really matter whether you're drawing these lines with straight lines or curved lines, as long as they're meeting up with the correct ones, it's all good. Then for the next one, it's a times a times a, which is basically looking at multiplying. So we're using powers because the base numbers or the whole numbers or the big numbers are the same. So a times a times a times a is going to be a to the power of 4. Then finally, we're looking at a plus b plus b. So joining the a's, we get 2a and we get 2b. So we're looking for 2a plus 2b, which is our last option. So we've got one there. Now notice how there are 2 blank. Again, that's not there to trick you, it's more to test your understanding, but also you don't want to be connecting more inputs to outputs in terms of looking at the expressions. Moving on to question 2, so let's just zoom in so we can see a little bit clearer on the screen. So it says that choose one of the following to make a correct statement each time. So the options are either we can say that it's less than, is equal to, or is greater than. Now with this particular question, I personally would substitute the numbers into both the expressions, both the left hand side and the right hand expressions, and then make your judgment from there. So here when a equals 3, 4a, which is 4 times a, so which is going to be 4 times 3, which is going to be 12. And then here we've got 3 plus 7, which is 10. So 12 is which of these statements, what it's going to be is greater than. Then for the second one, when b equals 8, we've got 2 times b take away 6. So 2 times 8 is 16, minus 6 is 10. And 18 take away 8 is going to give me 10. So that there is equal to. Then for the third one, we've got c equals 0.5. Well, 3 times 0.5, we'll think about it as 3 50p pieces. Well, that's going to be £1.50. And 50p plus £1 is £1.50. So again, that is going to be is equal to. Then for the last one, it says d equals minus 1. So d is just going to equal minus 1. And d squared, well, that's going to be minus 1 times minus 1. A negative times a negative is a positive, and 1 times 1 is 1. So that's going to give me an answer of positive 1. So this one is going to be is less than. Now, could you get away with using inequalities? I personally would not, because it does say choose one of the correct statements. So again, if you did use inequalities, will you get the marks? Potentially yes, but I would always try and write it in the format that they have requested. Moving on to question 3, it says the formula converts degrees Celsius into degrees Fahrenheit. And we've got the formula. It says use the formula to convert 28 degrees centigrade into degrees Fahrenheit. Give your answer to the nearest whole number. So for this, all we need to do is substitute the numbers in. So here we know that C equals 28. So then substituting that, we get 9 times 28 divided by 5 plus 32. Now, if you're not sure about where that comes from, why it looks a little bit different, well, 9/5 times 28. Well, if I convert the 28 into a fraction, it still then gives me 9 times 28 over 5. So that's why this comes into play. Now, if I then type that all into my calculator, I'm going to assume this is going to be a calculator question, I get an answer of 82.4, and then we just need to round up to the nearest whole number, which is going to give me an answer of 82. Then moving on to the next question. Now moving on to question 4, it says match the algebra to the correct description. One has been done for you. So for the next one, we've got 6x equals 24. Now when we've got an equal sign and only one letter, then that's going to be an equation. When we don't have an equation, when we don't have an equal sign and we've got multiple letters or a single letter, that there is going to be an expression. So the correct matchup ones are the ones you can see on the screen. Then moving on to question 5, again another matchup one, which says link the algebra to the correct description. So again, looking at number 2, the first one's been done for us. So looking at the next one, we can see we've got actually got a triple equal sign. So that there is going to be an identity straight away. Anything with that triple equal sign is always going to be an identity. Then for the third one, you can see we've got one letter and an equal sign. So that's going to be an equation. And the next one, we haven't got an equal sign. So that is going to be a expression, which is at the bottom there. It's a bit panicking there. And then finally, we've got 3x plus 2 is less than 14. And that is obviously going to be an equality. Why? Because it's got an inequality sign. Moving on to question 6, it says expand 4x squared and then times 3x plus 5. So we expand the brackets knowing that we multiply numbers with numbers, letters with letters. So 4 times 3 is 12. X squared times x is x cubed. Then we've got a plus, and then 4 times 5 is 20. And then we've got x squared, so that gives us our second option. Moving on to question 7, it says simplify fully. So again here, what we're doing is just multiplying all the numbers together, all the letters together. So here, starting with the numbers, we've got 5 times 3 times 2. Well, 5 times 3 is 15, times 2 is 30. Then looking at the x's, we've got x squared and another x, so that's going to be x to the power of 3. And then for the y's, we've got y to the power 4 times y to the power 3, so I've got 7 in total. Moving on to 7b, it says expand and simplify. So again, if you want to use a table or you want to use loops, whichever floats your boat. So here we've got x squared minus 3x, and then we've got 7 times x, that's plus 7x, and then plus 7 times minus 3 is minus 21. Then all that's left is for us to combine these two things together, in which we get an answer of x squared plus 4x minus 21. Then moving on to 7c, we just want to solve this. So again, we make each bracket equal to 0. So here we take the 8 over to the other side, so we get x equals 8. And then if we do the same for the other bracket, so then we end up with x minus 2. So x equals 8 or minus 2. Then moving on to 7d, it says factorize. We've got 8 and we've got numbers, we've got x's and we've got y's in each term. Now with the numbers, you want to take out the highest common factor. With the letters, you want to take the lowest power out. So here looking at 8 and 6, the biggest number that goes into 8 and 6 is going to be 2. The smallest power of x that both of these two things have got is x, and the lowest power of y that both terms have got is a single y. So that's what goes outside the bracket. So next it's a case of what do I need to multiply 2 to get 8x squared? Well, that's going to be a 4 to make the 8. I need another x and the y I've got, so that's absolutely fine. Then for the next one, what do I need to multiply 2 to get 6? Well, I need a 3. I've got a single x and I've got one to single x, so that's fine. I've got y, but I want y squared, so I'm going to need another y. So the final answer then is 2xy outside the brackets, and inside the brackets 4x plus 3y. Moving on to question 8, it says circle the expression equivalent to x squared minus 4x minus 12. So for this we're just factorising, so we're thinking of two numbers that multiply together to equal minus 12 and two numbers that added together that equal minus 4. And here another alternative you could do is basically expand all the four brackets and see which one gives us this expression here. So again, looking at the first method of trying to factorise it, our two numbers are going to be minus 6 and positive 2. So minus 6 and positive 2. So then what we're looking for is positive 6 and minus 2, in which this is going to be our correct answer. Now if I did go through the process of expanded brackets, this one here is going to be x squared minus 12x plus 32. This one here is going to be x squared minus x minus 12. This one here is going to be x squared minus 11x minus 12. And then this final one is going to be x squared minus 4x minus 12, which is the one that we wanted. For question 9, it says Kelly charges for babysitting. She uses this formula, and it says one evening Kelly babysits from 6 p.m. to 11 p.m. and her taxi fare is £8. And the question is asking us to work out the charge. So here we know that the number of hours worked is going to be 5 hours. So the total charge is going to be 6 times 5, and then we need to add the taxi fare, which is 8. So 6 times 5 is 30, plus 8 gives Kelly £38 earned. It then says the next evening Kelly babysits for 3 hours and she charges £23.75. How much was her taxi fare? So for this, we first of all need to work out the actual cost of her in terms of hours. So we've got 3 times 5. Now we know that she charges £6 an hour, I should say. Gotta check that because that would have been wrong. So here we've got 3 times 6, which is 18. So then if we look at the taxi fare, well, that's going to be £23.75 minus 18, which is going to come up to £5.75. And that's all I need to write here. Then moving on to question 10, it says rearrange, and we've got y equals x over 3 plus 9 to make x the subject. So the first thing we need to do is take the 9 over to the other side. So we end up with y minus 9 equals x over 3. And then we just want to get rid of the 3. What's the 3 doing? Dividing. What's the opposite of dividing? Multiplying. So we then multiply everything on the left hand side by 3. So 3 times y is 3y minus 3 times 9, which is 27. And that's what equals x. Moving on to question 11, it says work out the values of a and b in the identity. Now for this, what we need to do is basically expand the brackets, collect the like terms, compare the coefficients. So here if we expand the brackets, we get 35x plus 40, and then we've got 3 times 2x, which is 6x, and 3 times b, which is 3b, and that is all equal to ax plus 13. So now if I just neaten the left hand side, so just neaten all of this up, I end up with 41x plus 40 plus 3b is equal to ax plus 13. Now comparing the coefficients, so what we need to do here, so if I compare the coefficient of x, well on this side I've got 41 lots of x, and on this side I've got just a. So that means that 41 equals a, and so there is my value of a. If I then look at the coefficient of the constant in terms of the other numbers or everything else, let's do that in a different colour. Let's go for lilac. So here we've got 40 plus 3b, and that must equal 13. So I've got 40 plus 3b equals 13. So if I now solve this equation, taking the 40 to the other side, I end up with 3b equals minus 27. Divide that by 3 and I get minus 9. So my two values of a and b are going to be 41 and minus 9. Now moving on to question 12, it says here is a number machine and it says that the output is twice the input. Work out the input. So if we know that the output is twice the size of the input, then if the input was x, because we don't know what that is, then the output is going to be twice of that, which is 2 times x, which is 2x. Now if I now go about solving this, we know that 2x is equal to 6 times x, which is 6x, take away 2. So then from this, what we then want to do is solve this. So what we end up with is, if we take the 2x over to this side, we end up with 0 equals 4x minus 2. We then take the 2 over to the side, so we end up with 2 equals 4x. And then if we divide both sides by 4, we get a half equals x. So x equals a half. Now moving on to question 13, it says points A and B are shown on the centimetre grid. And for part A, it says draw a rectangle ABCD on the grid with area 12. Now with the distance being between A and B being 4 squares, 4 times what gives us 12? Well, that's going to be 3. So what we're looking for is either this rectangle here or this rectangle here. So there's going to be a few answers you can give for this particular one. Now, when we're looking at shapes and you're talking about vertices, generally speaking, you want to have one continuous root. So here if we've got A, B, so that means C is going to be here and D is going to be there. So, and that's so what you want to do is either draw, for part A, you either want to draw the blue rectangle or you want to draw the orange rectangle. Let me just have that. So it's blue and orange. Then says write down the coordinates of C and D and point to the point. So here, if we're looking at the blue, this is going to be C, this is going to be D. So let's just call that C1, D1. And for the orange, this is going to be C2, and that's going to be D2. So if you're using the blue rectangle, then C1 is going to be at 7, 8, and D1 is going to be at the coordinate of 3, 8. Or alternately, you could have the orange rectangle in which you've got C2 at 7, 2 to all you Liverpool fans, and D2 is going to be 3, 2. And there we go. So any of those two pairs will be good enough for your answer for 13b. Moving on to 14a, it says complete the table for y equals 3x minus 1. So for this, what we need to do is substitute the x value into the formula to then get the respective y value. So for this one here, it's going to be 3 times minus 2, which is minus 6, take away 1, which is minus 7. Then for this one here, it's going to be 3 times 2, take away 1, which is 5. Then for question 14b, it says on the grid, draw the graph of y equals 3x minus 1 for the values of minus 3 to 3. So for this, we need to use the table of values that we've drawn. So for the first one, we're looking at minus 3, 10, or minus 3, minus 10 rather. So that's going to be here. Then we're looking at minus 2, 7, which is there. Minus 1, minus 4, which is there. Then at 0, it is minus 1, which is there. 1, it is 2. At 2, it is at 5. And at 3, it is at 8. And again, that should be almost a perfect diagonal line. Then all that's left is for us to join the points up with a straight line. So let's just use a different colour so it stands out a bit. Now, one thing I would recommend that you do is maybe not focus on the ones where it's in between, like the odd numbers of y, and just focus on the even numbers because they're just going to be a lot easier to plot. But you should have something that looks like this. Now if you wanted to, I would always strongly recommend that you extend the line up to the edge of the squared grid, but ultimately as long as you've got -3 plotted and 3 correctly plotted, then that is going to be absolutely fine. But make sure that you do join those points up with a straight line. Moving on to question 15, we can now zoom in because we've got no graph paper. It says that circle the equation of the line that is parallel to y equals 5x plus 2. Now what determines a parallel line is basically having the same value of x when y is the subject. So here we're looking for anything that's got positive 5x and y is the subject for all of them. So the correct answer we need to circle is going to be the second one. Question 16, it says that a straight line has a gradient of 4 and passes through the point 5, 23. Work out the equation of the line, give your answer in the form of y equals mx plus c. Now here the gradient is 4, so that's the m value. So what we've got is y equals 4x plus c. Now from the coordinate, this is my value of x and this is my value of y. So what we're going to do is going to substitute those numbers in to find out what c is going to be. So if I just highlight this to begin with, then I substitute x equals 5, y equals 25. So x equals 5, y equals 23. So I end up with 23 equals 4 times 5 plus c. 4 times 5 is 20, so 23 plus 20, equals 20 plus c. And 20 plus what gives you 23, so c equals 3. So then joining these two things together, we get our equation of y equals 4x. And instead of writing c, we know that c equals 3. So it's going to be positive 3. And there is my answer. Moving on to question 17, it says that a line has the equation of y equals x plus 3. Write down the coordinates of the point where the line intersects the y-axis. Now where it intersects the y-axis, that's when x equals 0. So if I substitute x equals 0 into this, I end up with y equals 0 plus 3, which is 3. So here we end up with y equals 0 plus 3, so y equals 3, and x equals 0, so the coordinate then is 0, 3. Then for the next one, it says write down the coordinates of the point where the line intersects the x-axis. Now for this, y equals 0, so I've got 0 equals x plus 3, so x equals minus 3, and these are the two coordinates we've got, so it's going to be minus 3 and 0. Moving on to question 18 rather, it says that here is the graph of y equals x squared minus 7x plus 10 for the values of x from 0 to 7. And for question 18a, it says write down the roots of x squared minus 7x plus 10 equals 0. Now the roots are basically where the curve crosses the x-axis. So for this, the roots are either going to, you can either write x equals 2 or x equals 5, or you can write them as a coordinate, which is 2, 0 and 5, 0. So any of those two ways of writing your answer will be absolutely fine. Then for B, it says write down the x coordinate of the turning point. Now the turning point is basically this point here, and we're just looking for the x value, and that's going to be between 3 and 4, which is 3.5. Then for 19a, it says complete the table of values for x squared minus x minus 2. So again, what we're doing is substitute the numbers of x into this formula here. So what we've got for this number, it's going to be minus 2 squared minus minus 2 minus 2. So minus 2 squared is positive 4. Minus minus 2 is plus 2 and minus 2. So 4 plus 2 is 6. Take away 2 gives me an answer of 4. Then for the next value, we're looking at x equals minus 1. So that's going to be minus 1 squared minus minus 1. Take away 2. So minus 1 squared is 1. Minus minus 1 is positive 1. Take away 2. 1 plus 1 is 2. Take away 2 is 0. Then for the third one, or this next one, we've got 2 squared minus 2. Take away 2. So 2 squared is 4. Take away 2 minus 2 gives us an answer of 0. Then for part B, it then says draw the graph of y equals x squared minus x minus 2. So again, if I just zoom out a little bit, I can then just see the table of values and the grid that I've got. So here we've got minus 2, 4, which is here, minus 1, 0, which is there, 0 is minus 2, 1 is at minus 2, and 2 is at 0, and 3 is at 4. Now this is going to be a U shape, so what you need to do when you're joining the points up is just make sure that you don't have a flat bottom. So it needs to curve up, making sure that your curve goes through. Hopefully yours is a lot easier, but it should be something that looks like this. And again, you want to make sure that your line goes through the points and mimics the U shape as much as possible. Moving on to question 28, it says on the axes make a sketch of y equals x cubed. So you want to draw a cubic graph, and your cubic graph should go through the origin and have a shape that looks something like that. Then for 28, it says on the axes make a sketch of y equals 1 over x. So this is a reciprocal graph and should look something like this, making sure that your two little curves do not cross any of the axes. Moving on to question 21, it says that Jenny leaves home at 06 hours. She runs for 3 hours. Here is a distance time graph of her run. And it says for 21a, it says how far home is she after the 3 hours. So here we're looking after the 3 hours. We want to look at the distance, so that is going to be 20. It then says for the next hour she rests. She then gets a bus home. She arrives home at 11:30. Complete the distance time graph. Assume that the bus travels at a constant speed. Well, if she stays rested for an hour, that means she's going to be stationary. Again, you want to make sure you're using a ruler. And then she arrives home from the bus at 11:30. So home is the bottom. So that's where she gets home. So all that's left for me to then do is with a straight edge, draw a line from that peak to 11:30. And again, you want to make sure that you're using a ruler so your lines are nice and straight. Moving on to question 22, it says the number of items n made in 1 hour by a machine is given by n equals 60 over t. T is the time in minutes the machine takes to make one item. The value of t changes for different types of item. For 22a, it says on the grid below, draw the graph of n equals 60 over t for the values of t from 1 to 40. So for this, what we need to do is write when t equals 1, we end up with 60 over 1, which is 60. So one coordinate is 160, which is there. When t equals 2, we end up with 60 over 2, which equals 30. So it's going to be 230, which is there. When t equals 3, it's going to be 60 over 3, which is 20. So at 3, it's 20. And when t equals 4, it's going to be 60 divided by 4, which is 15. So at 4, 15, which is roughly about there. And again, what you then want to do is potentially draw a curve going through each of those plotted points. Then for B, it then says the machine takes 3 minutes 30 seconds to make one item. Use the graph to estimate the value of n. Well, 3.5 is here. So if I just go up the graph of 3.3 or 3.5, and as soon as it's the graph, I then want to project across. Now, whatever number this is, that is the number you want to write down. So regardless of your diagram, how you've joined it up, but I'm going to assume it's roughly around 15, but I would accept any answer between 14 and maybe 17 potentially. Now moving on to question 23, so let's just zoom in a little bit so we can see that all in. We get solve 6x minus 11 equals 13. So here we want to get rid of the 11, so we add 11, so that becomes 6x plus 24. Well, I've got a plus there, so let's just get rid of that. Equals, and then we get rid of the 6 by dividing by 6, so x equals 4. Then moving on to the double-sided equation. Again, with double-sided equation, you always want to get rid of the smallest amount of x. So we take away 2x from both sides. So we end up with 6x plus 7 equals 10. And then we get rid of the 7, so 6x equals 3. Get rid of the 6, so it becomes 3 over 6, which is the same as a half. Or you can write it as a decimal. Then moving on to question 25, it says solve x squared minus x minus 12 equals 0. So again here we want to factorize. So again, think of two numbers that multiply together to equal minus 12, but added together equal minus 1 because we've got minus 1x. So the numbers you're looking for, again, I can use 4 and 3, 6 and 2, 1 and 12. So the only sets of numbers with a difference of 1 is 4 and 3. And because I want minus 1, it's going to be minus 4 and positive 3. So minus 4, positive 3. And then what I then need to do is solve this. So I've got x minus 4 equals 0. So x equals 4. And then from this one, we've got x plus 3 equals 0. So x equals minus 3. So the two values are minus 3 or positive 4. And you can write your answer in any order. Moving on to question 26. So here we're looking at simultaneous equations. It says solve the simultaneous equation. Now for this, what you want to do is you want to have the same number of x's or the same number of y's. Now for this, we have already got the same number of y's. So all I need to do is then decide whether to add or subtract. Now as you can see with the y's, they're both the same sign, they're both different signs. So what we need to do here is add the two equations. So 2x plus x is 3x. The y's disappear, and 18 plus 6 is 24. So then from this we can then establish that x equals 8. Then using the second equation because it looks more easier, so we've got x minus y equals 6. We know that x equals 8, so I've got 8 minus y equals 6, or 8 minus something equals 6. What's that something going to equal? Well, it's going to equal 2. So my answer for this particular question is going to be x equals 8 and y equals 2. Moving on to question 27, it says S and T are rectangles. S has the dimensions of x plus 2 and x. Some of these rectangles make a larger rectangle as shown. Work out the expression for the perimeter of T. Give your answer in its simplest form. So for this, what we need to do is first of all label all the parts that we've got. So this side is going to be x. This side here is going to be the sum of these two things here. So we've got x plus x, which is 2x, and 2 plus 2, which is 4. And then if this is, all of this is x plus 2. If this bit here is x, then that means that this bit here must be 2. Then from this, we can then work out the perimeter of T. So if I just take T out, I've got 2x plus 4, I've got 2, that's 2x plus 4, and that's 2. So the perimeter is going to be 2x plus 4 plus 2 plus 2x plus 4 plus 2. Then all I then need to do is collect all the like terms together. So looking at the x's, I've got 2 plus 2, which is 4. And then looking at the numbers, I've got 4 plus 2, which is 6, plus 4, which is 10, plus another 2, which is 12. So my answer then is 4x plus 12. Or if you want to factorize that, you can have 4 and then x plus 3. So any of those would be absolutely fine. Moving on to question 28, it says solve 4x minus 7 is less or equal to 13. So again, we solve this in exactly the same way as if it was an equal sign. So we want to get rid of the 7. So I've got 4x is greater or equal to 13 plus 7, which is 20. I then divide both sides by 4, in which then I get x is less or equal to 5. Then for question 28, it says show this on the number line. So we've got a circle on 3, we've got a circle on 8. As the inequality next to the 8 is got an equal sign, we can colour that in. And then we just simply join those two circles with a straight line. Moving on to question 29a, it says the term-to-term rule of a sequence is add 8 and divide by 2. The first term of the sequence is minus 24. Work out the next two terms. So if the first term is minus 24, then we need to add 8 and then divide the answer by 2. So minus 24 plus 8 is going to give me minus 16. And then we divide that by 2, in which I get an answer of minus 8. So here, my next value is going to be minus 8. Then starting with minus 8, if I then add 8, I end up with 0. and then divide that by 2, and I get an answer of 0. So my two answers are -8 and 0. Moving on to question 29b, it says the term-to-term rule of a different sequence is subtract 1 and multiply by 5. The third term of the sequence is 120. Work out the first term. So to go in this direction, I need to take away 1 and times by 5. But if I want to go in the opposite direction, I need to do the opposite of this in the opposite order. So the opposite of multiplying by 5 is dividing by 5, and the opposite of taking away 1 is adding 1. So 120 divided by 5 is 24, and plus 1 gives me an answer of 25. Then doing the exact same, so 25 divided by 5 is 5, plus 1, which is 6. So the two missing, the first and the second, or the first term, is going to be 6. Then moving on to question 30, the sequence of pattern uses grey squares and white squares. Here are the first 4 patterns. And for 38 it says work out the total number of squares in pattern 100. So for this, what we need to do is we look at the pattern number and we want the total number of squares. So for pattern number 1, we've got 6 squares. For pattern number 2, we've got 9 squares. For pattern number 3, we've got 12 squares. And for pattern number 4, we have 15 squares. So what I need to do is find basically the nth term of these numbers here. So again, to find the nth term, we look at the difference, which is plus 3. So that means we're going to have 3n. And then starting with 3n, what do we need to add to get to 6? We need to add 3. So this is the formula we need to work out for the total number of tiles. So if we've got pattern number 100, we've got basically, we're going to end up with 3 times 100 plus 3, which gives us an answer of 303. Then for question 30b, it says complete the number machine for the sequence of patterns. So you want the number of grey squares to get to the number of white squares. So for this, if we set up a little table, so we've got the grey and we've got the white. Now in the first pattern, when we've got 1 grey tile, we've got 5 white tiles. When we've got 2 grey tiles, we have 7 white tiles. When we've got 3 grey tiles, we've got 9. So what we need to do is then find the pattern or the nth term from this. So here we can see that the difference between the white tiles is plus 2. So that means we're going to end up with 2n. And then what do we have to get from 2 to get to 5? Well, we need to add 3. So it's going to be times 2 plus 3. Then moving on to question 31, it says match each sequence to its description. So here, if I just zoom out a little bit, we've got all of them. No, we haven't. So let me just get them all on screen. So looking at the first one, hopefully you can recognize that that one is going to be a geometric sequence because the numbers are doubling as we go along. For the next one, you can see you've got consistent difference between each of the numbers. So that is going to be an arithmetic progression. For the next one, that is going to be triangle numbers. For 1, 4, 9, 16, 25, 36, they are square numbers. And 1, 8, 27, 64, 125, and 216, they are cube numbers. Then moving on to question 32, it says work out the next term of the quadratic sequence. Now in a quadratic sequence, you always end up with a double difference. So here, if we work out the difference between the numbers, here we end up with plus 3, plus 6, and plus 9. So as you can see, the differences are going up in the 3 times table. So that means that the next difference is going to be 12, and 23 plus 12 gives us an answer of 35. So then moving on to question 33, it says the nth term of a sequence is 2n plus 1. The nth term of a different sequence is 3n minus 1. Work out 3 numbers that are in both sequences and between 20 and 40. So for this, what we need to do is first of all write down the terms that are in 2n plus 1. So again, starting with the numbers, the first number is going to be 3, and the difference is going to be plus 2. So I've got 3, 5, 7, 9, 11. Now, basically, they're all going to be the odd numbers starting with 3. So looking at the odd numbers between 20 and 40, well, that's going to be 21, 23, 25, 27. Oh, Missed that one out. 27, 29, 31, 33, 35, 37, 39, 41. But the only ones that we're interested in are the ones between 20 and 40, which are these ones here. Then for 3n minus 1, we do exactly the same. So 3 times 1 is 3, take away 1 is 2. And then the difference is going up in 3s. So that's going to be 2, 5, 8, 11, 14, 17, and then 20, 23, 26, 29, 32, 35, 38, and 41. And again, we're only interested in numbers between 20 and 40. So here I'm just looking for 3 numbers that appear that are highlighted in yellow and in pink, in which they are going to be, and if I pick a colour that I've not used, let's go for red. So they are going to be 23. They are going to be 29. And finally 35. And again, you can write those numbers in any order. Then moving on to our last question, it says the first 4 terms of a linear sequence are 7, 11, 15 and 19. Circle the expression for the nth term. So again, difference between these numbers is plus 4. So we're going to end up with 4n in our formula. And what do you have to add to 4 to get our first term, which is 7, add 3. So we're looking for 4n plus 3, which is our second option. And that concludes the end of this algebra audit on the foundation syllabus.